All right, you masterminds, here we go again. I ran out of time on that last one, so I'm going to continue on and emphasize again something here that I forgot to mention on this part right here. When we talk about angle 7, we talk about angle LHG. We want to emphasize again that H is always the vertex. So if we wanted to, we could also, if it's the only angle, we can sit there and go angle H as well. The only problem is that when we talk about angle H, that means if there's more than one thing coming off it, but there isn't, so therefore we can use angle H as another identifier for that one as well. Okay, so with that being said, let's go ahead and move on to the next page of our notes. And here's what I'm going to have you do, is I want you to go ahead and do the same thing. Remember, you can access all this stuff in the book too to help yourselves out. Okay, so with that being said, let's go ahead and move down again to the notes, and this is still part of section 1.4. All this is video stuff, even though it sometimes says video, sometimes it says in class scenarios. Okay, now a degree. When we talk about degrees, and you guys have seen a protractor before, hopefully at some point, and learned how to use them, this is what we're going to talk. A degree is our angles are measured in units called degrees. The degree results from dividing the distance around a circle into 360 parts. So a degree is basically a measurement of 360 parts of a circle. Okay, now as you can see, we have a half of a circle here. As you can see that we have 180 degrees on each scenario. Now notice that this side also has 0 and 180, and it counts this way and then it counts backwards going this way. So it depends on what side you go from. It says right here, align the 0 on either side of the scale with one side of the angle. So you need to take one ray. So here's our angle F, E, and D. We're going to take this ray right here, and we're going to line it up right along the 0 marking here. E, there's always a hole in the middle of that, and you're going to put a hole right over the top of the vertex here, okay? Now, which one do we count? Because a lot of people will go, oh, 180 degrees. They'll look on the outside, and they'll go, oh, it's 130 degrees. That's not necessarily the case because we're counting backwards. Remember, we want to count from 0 and up. And if we were to go this way, we'd look at this one here going up, and it would be 50 degrees. So let's read this. Since ED is lined with a 0 on the inner scale, which I just talked about, then you'll find the EF intersects of the scale at 50 degrees. Okay? And then if we would have done it from this side, it would have gone on the outside, not on the inner side. Place the center point on the protractor, which I said. The protractor has two scales running from 180 degrees. We mentioned that as well. Okay, now we have three types of angles that we're going to specifically identify with throughout this within geometry. Okay, so let's move down. Here we go. Here's our three. We've got a right angle, an acute angle, and obtuse angle. Now notice a right angle. There's a symbol here that I'm highlighted in red. And this right angle automatically means that we are going to call this 90 degrees, okay? Anytime that we have where it looks like an elbow or a square of any kind, and this little symbol is down here in the corner, that means this is automatically going to be 90 degrees. Okay, now, next part is what is called acute. That means anything that is between 0 and less than 90 degrees. Now, the way I think about acute is, you know, sometimes at some point in your life, you either had a smaller brother or sister, or a cat that was a kitten, or a dog that was a puppy at some point, and we always sit there and say how cute they look because they're so small. Get it? So anything that is small and smaller than 90 degrees is going to be acute. Okay, I hope you like that idea about that. Now, same thing with this one where we have obtuse. Okay, that means that it's going to either be anywhere higher than 90 degrees and less than 180 degrees is called an obtuse angle. And I don't mean to, in this way, doctors use this word with people that are overweight or have a weight problem. Sometimes they say that they're obese is what the word I'm looking for, obese. So I think about the same thing. Obtuse kind of means the same thing as obese. We mean they both start with O. That means they are bigger than 90 degrees and less than 180 degrees, as we can see here. So again, as you can see, the symbol in both of these, going back to acute, notice that it's smaller than, it's with inside 90 degrees, where this right angle here is larger or outside of the 90 degree measurement, so that makes it obtuse, okay? Now, the other one that we have out there that I mentioned earlier, and it's not written in there, but you can put it at the bottom of your paper, is called a straight angle. And we mentioned that before, but we're going to talk about it again. It's equal 180 degrees, okay? So that means an angle that looks something like this, if we were to have that, okay? And there's no right angle in that one. If we were to draw a dashed line like this, it would be straight down, and then we would put our right angle that way. So that would be what is called a straight angle in that case, okay? Any questions on that? Hope that helped you out with some examples there. All right, let's go on to the next page. Okay, let's move down here. Let's check out. Now we're going to start identifying these angles as either right, acute, or obtuse. So let's do these in different colors to help you out. So let's look at the first one, M. So M, J, and P. So what do you think that one is? I'm looking right here and I can see this. I'm going to highlight this in here so we know that it's there. It's our right angle. So guess what this one is? 90 degrees. That means it is a right angle. Okay. Let's look at the next one. Let's do a different color. Let's go light blue this time. Let's go L. And let's go to J. And then we're going to what? P. So it's again along this line right here. Again, here's our 90 degree based on the green. Is that going to be, is that inside the green line or is it on the outside? Looks like it's on the outside, so this one would be what? Obtuse. Now it says to use a protractor to measure those if you want to, and we can do that if you'd like. I'm just going to, based on time, we're going to look at this and we're going to sit there and have it. I don't have a protractor with me, but they say this one is 105 degrees. Okay, and then we're going to take N. So let's go like a maroon color. N, which is right here, to J to P. So here we go. So we got this one here, and we know that it's going to be here. So we know this one's going to be, because it's smaller than acute. And according to the book, is what they said here, if you were to measure it out, it would be 20 degrees. Okay, so now it's your turn, and I would give you some time on that and check it out and measure those ones. If you don't have a protractor, just tell me whether they're right, obtuse, or acute in these scenarios, and we will go from there. All right, moving down a little more, just seeing how much more we have to do. We are almost done. Okay, now we're talking about a same word that we've used before. Does anybody recognize what word that is? Bisector. Okay, bisector basically does, again, bi means two, sector means we're cutting it in, cut in half. Okay, so as you can see, and I've talked about this before, I make arcs inside these angles. So W, Y is called our angle bisector. Why is it called the angle bisector? Because it cut this whole angle, if we mark it in green, an arch, in half, where each side is equal to 80 degrees. Okay? So that means if it's cut in half, that if this is 80 and that's 80, that means they're equal to each other. That means they are congruent, and therefore it is a angle bisector. So this WY is your angle bisector. It's also considered to be a ray that cut it in half. So if I were to ask you the question, how many degrees is this total angle of x, y, and z? If this side is 80 and this side is 80, that means this whole thing is going to be 160 degrees total. Okay? All right. With that being said, let's go ahead and move down to our first example with bisecting. Remember, cutting things in half. Now we're going to use a little bit of algebra to figure this part out. Okay? It says in the figure, KJ and KM are opposite rays, so KJ and KM, when we talked about this, is called a straight angle. Okay? And then KN bisects angle JKL. So let's mark that. So here we go. So let's mark this as the angle that we're looking at. Okay, I'm highlighting that in green. And then they said that this one bisects it. So this one's basically cutting that thing in half. So I'll call this the AB, okay, the angle bisector. It says if the measurement of JKN is 8x minus 13, okay, and that means the other side, it says the measurement of NKL is 6x plus 11. They're asking us to find the whole measurement of, what is it? That's what I told you. In the trick, it says to find the measurement of JLN. So JLN. That doesn't make any sense. So I think it's supposed to be JK. So we're going to assume, because that's a typo in there, we're going to find out what the measurement of that angle is. Now, as we mentioned, this red line is an angle bisector. That means it cuts these two in half. That means, as we mentioned up here, that these two are equal. That means that these two are equal. Therefore, we're going to set them equal to each other. So we're going to go like this. 6x plus 11 equals 8x minus 13. Okay? Now all we have to do is just solving some algebra, where I'm going to move my 6x to both sides by subtracting, giving me an 11. Gives me 2x minus 13. Okay? And we're going to go ahead and add 13 to both sides. That's canceling out, gives me a 2x equals, what was that, 24? And then we divide both by 2, and x equals 12. Okay, now, sometimes we think that this is our answer. But again, trick again, here we go. It says that we need to find the measurement of this specific angle right here. So what we need to do is we need to plug this 12 back into here and solve for that part. So let's go ahead and do that. So we're going to go 8 times 12 minus 13. So what is 8 times 12? Where's my one handy dandy calculator? I just can't seem to find it. Where did it go? I'll have to use my phone. Hold on a second. Here we go. So 8 times 12 equals 96. So we're going to get 96 minus 13. So I'm going to subtract 13 from that. And we get an answer of 83 degrees. So this side is 83 degrees. That means if this is the angle bisector, this is what? 83 degrees as well. Okay? Alrighty. So let's flip the page here. And guess what? It says it is your turn. And I want you to do the same thing, and I label them, and I bet you, and I would just encourage you to get colored pencils, pens, whatever you want to call it, but it helps out to do that. That's why I have these things to do that, and you have an idea of what's going on. Okay? So if you have any questions, concerns, we are done for the notes for this portion of up to section 1.4, and I hope that you are getting some stuff out of this. And like I said, if you have any questions, just need to ask me. All right, have a good one. We'll talk to you later.